So, welcome everybody to another episode of Software Architecture on Stream, this time with Bert Jan Schrijver. Hi, I
Hello.
hope you're doing well. And we are going to talk about generic versus specific, which is probably one of the interesting questions around software architecture. So, do you want to say a few words about yourself first?
Yes, sure. So my name is Bert Jan. I'm CTO at Open Value. We're a consultancy mainly focused on Java with offices in 4 countries. I have a background as a Java developer and software architect, and I'm also active in the board of the NLJUC, the Netherlands Java User Group. We organize a couple of conferences. So I'm fairly Java focused, but on the end, most design topics are quite independent of any language specifics.
Excellent. And I should mention that you're going to talk about the same subject at the Software Architecture Gathering, and which is a virtual conference, and we have a rebate code, which I will also give in the links and in the show notes for 15% off. That's a virtual conference, so you can join from almost anywhere, and I think it has quite a lot of interesting topics around software architecture. So that is something that, that's one of the reasons. So this is one of the Software Architecture Gathering specials. We will have another one next week on, I believe, Wednesday evening, and then the regular episode on Friday. Okay, so first question, so you're giving a talk about that. We are spending an hour discussing this topic. So why would we even bother with generic and specific solutions? Why is this so very important?
Yeah. So, I guess as a developer or architect, you're constantly either conscious or unconsciously making design decisions, right? And if we're talking about generic versus specific, I would talk about solving something in a specific way, so specific designs for something really local, maybe in one class or in one project, or solving something generic. So a generic solution that's used by multiple pieces of code, by multiple projects, or by multiple teams even. And I think as developers, we are taught what good and clean code looks like when we start our careers, and we're taught stuff like you shouldn't repeat yourself and all those things that we'll probably touch on later. I think it's good for every solution you need to make for a problem to be consciously thinking about, should I make a local solution for this? If something is really local, then it's also typically fairly simple and easy to understand. Or does it pay off to make a more generified solution that I can use in multiple places? But then both ways can work out fine. But then I think the important question is, how do you decide whether solving something small, specific, local, or making it bigger, reusable, and generic? And I've seen throughout my career that I've changed a bit. Whereas when I was a young and aspiring developer, I wanted to make stuff as useful and generic as possible, because then for every problem, I could think about all the possible use cases and design something that was so generic that any future use case would fit at it. And now I'm a bit more towards, okay, I cannot predict the future. That's the one thing I'm sure about. Therefore, I can probably also not design something that can handle all future use cases. So then probably it's better to make something really simple that fixes one problem at hand. And then once we learn more about the future, think a bit more about generic solutions.
Mm-hmm. And I think it's interesting that you already mentioned the DRY principle, which we are going to talk about later on, because that also puts an emphasis on the generic solution, because otherwise you will need to repeat yourself. So I think that's interesting. So one of the things that you covered in your talk is the relation between generic solutions and coupling. So yes. What is coupling, first of all?
I'd say coupling is when there's interdependencies between 2 building blocks of your software. Can be classes, components, services, whatever. And you typically find out that you have coupling if you want to change something in one place, and then something else that you don't want to change need to change as well. Then there's coupling between those. And coupling is not necessarily a bad thing. I think any non-trivial application needs coupling. But obviously, there's a difference between loose coupling, where 2 components are not coupled too tight, and it's fairly easy to change one without needing to change the other. and tight coupling, where they're really interconnected, and anything you change on the left side also has implications on changing it on the right side.
So what's the relation between a generic solution and coupling then?
Yeah, I think the point is that if let's say you have a local problem in one class, and then you want to basically reuse the solution you have here in another class. There's basically two options. You can copy the one class to the other, then you have duplicated code, but they live independently of each other in different places. Obviously, the downside is that if you need to fix something here, then you probably also need to fix it here. The alternative is that you make a generic solution. So you have one solution here, you extract some generic behavior, and then you have the other point depend on this, and the first point depend on that as well. And the point is that as soon as you genericize something, you're introducing coupling, because those two classes that are using the generified solution, they're both linked to the generified solution. And maybe if you want to change something on the left side, that is only impact on the left side, but changes something in the generic solution, the other side needs to change as well. So therefore you have coupling. So I think the main downside of creating generic solutions is that they increase coupling in your application. And therefore I think it's good to always really think well about, am I going to copy this and have duplicated code, which by itself may be a bad thing or not, or I'm going to make something generic where you have code reuse and it's nice solved in a single place. But the drawback there is that you have coupling to that generic solution.
Mm-hmm. And therefore, as you said, it's basically a trade-off. It's not clear that it's always the way to go go for a generic solution. So Duderoot on YouTube said, besides the cost which limits your decision when you want to go with the generic approach, looking forward to your argumentation pro and cons. Shall we talk about the cost of a decision to go for a generic solution right away? Because we plan to cover it, but we might as well cover it right away.
Yeah. So I think the point is that if you need to decide whether to go for generic or specific, there's a couple of things you can think about, like future evolutions and needs of your system. I mostly try to see this as risk management. So if it's a choice that I can postpone or make later, then I can go with the simplest solution I can come up with now. If I'm pretty sure that this will have a huge impact in whatever I'm going to do in my system, okay, then maybe I need to think about it a little longer. And that kind of also brings us to the question of what is the cost of generic solutions, right? Because this is also a trade-off that you need to think about. So a generic solution may save time, but it also may cost you time. If you think about, having a really simple specific solution that's typically easy to build and fairly easy to maintain. And then if you have a choice between copying it to another place or making something generic, well, then it depends on how good your generic approach is there. So if you get the problem domain and the solution domain and the abstractions, if you get them exactly right the first time, then probably it's less work to make it generic because you don't need to do everything over again. On the other hand, if you get those abstractions wrong, and you now have to maintain bad abstractions, understand bad abstractions, etc., in the end, over time, it may be more expensive. Generic solutions are typically a bit more complex because you're introducing some level of interaction, some level of abstraction. They may be in a different place, in a different code base, maybe more difficult to understand. If you have a really simple, specific solution, it's these lines of code that fit on my screen. But if there's all kind of calls to generic libraries in between, it may be harder to understand. So I think long term, typically an advantage that's being said of generic solution in long term is long term it will save time because we can reuse all kinds of code. But we should also think about the extra, let's say, cognitive load and complexity that it will cost you on the long term on onboarding new people in the team, understanding generic solutions, maintaining them and maintaining bad abstractions, etc. So I think the hard thing about making those choices is that it's often not really clear what will be the solution that costs you the least amount of time, both short term and long run. And in the end, we need to be aware of both and try to make a weighted decision there. And my general experience there is that you typically don't know when you're starting out with something, whether something is going to be a good decision in the long run. And this is actually the hard point here.
Mm-hmm. And what I found interesting about what you just said, and also what you say in your presentation, is that there is a social impact on the concerning the generic solution, concerning onboarding and these kinds of things, which basically means that if I have that generic solution somewhere, then people need to be aware of it, and I need to educate them about it. And I think that's probably not obvious. So I thought it was a good point that you made there. I'm not sure, I'm not sure whether we want to comment on that or talk about that. He just said, but can we not just create an extension in the generic solution so that it only works for dependency A and still work also with B?
Oh, yeah, sure. So the point is you have a generic, if I understand the question correctly, you have a generic solution that's used by A and B. Then you want to extend something that's that only matters for A without changing B. Then obviously it could work to put something in between, right? But now we have a code to maintain in 4 places. Whereas if you wouldn't make it not generic and copy it, you have it in 2 places. So yes, by all means. But I think if you figure out that you've made something generic, and now you want to change something in the generic code that only impacts one of the components that depend on this, and you need to make another abstraction there. Maybe the generic solution wasn't as generic as you thought it was. So if it's generic, then it should probably be usable by most of the components that use it. If you need to change something in a generic solution specifically for one of the dependents, okay, then maybe your abstraction is not the right one. Mm-hmm. But by all means, you can use object-oriented techniques to have something in between there, definitely.
Yeah, I think it's a good point that you just made, that it's then probably not really truly a generic solution anymore, because there is a solution for A and a solution for B, which is, well, pretty much not generic. Tutrud said that you got the question correct, so that's great. And he also said, of course, the generic part becomes more complex, but I will not see the dependencies so strict. Am I wrong?
No, I guess you're right. What you typically see, it's typically hard to know from the start whether you chose the right interaction or the right abstraction. So if you have 2 use cases, you can make something that fits those 2 use cases, but you don't really know whether it's actually the right one if you have the 3rd or 4th use case. And typically, this is something you see emerge. So if you feel the need to add additional abstraction layers, like something in between, or you see that your generic code leaks details from its dependents. So if there are all kinds of ifs or Boolean parameters or whatever, this can kind of get you thinking and moving in a way that this is not the right abstraction and the right level. And it may even cause you to throw everything overboard and move back to a specific solution. In the end, once you've made something generic that's used in 3 places and you figure out it doesn't work, you can still bring the parts of the generic solution to all local parts and then make it a tailored solution there. And in the end, you may end up with 3 pieces of simple code as compared to 1 shared piece of complex code. But obviously, it's difficult to reason about this without having actual use cases and code at hand.
Yeah, Teodoro just said, I agree 100% with the generic part, which will get damaged, not so generic anymore. So I think that was a good discussion. And because I think we sort of already mostly touched on it. So do you want to talk about your rule of 3?
Oh, yes. It's rule of 3 is a quite simple rule. And well, I'm a simple person, so I like simple rules. The rule of 3 says that if you need to solve a problem, the first occurrence of the problem you find, just solve the problem at hand. Apply the Yagni approach. You ain't going to need it yet. Solve the simple problem at hand with simple code. Then once the second use case comes along, try to find common behavior between those second use cases, refactor the initial code a bit, but still copy it. So you have it in 2 places. And not until the third case comes on for the same problem, then you can find a common ground between the 3 use cases and find out what's really generic. Then you can probably, by looking at the code for the first 2 components, extract a generic component that will actually fulfill the requirements for those 3 and fit on those. And I think the problem is that often, people are already talking about a generic solution in the first use case, or maybe in the second use case. And then if you go all in generic after the second use case, and then the third use case doesn't fit, well, then you may need all kinds of parameters or if statements or additional indirection layers. So I think we should be honest to ourselves and say to ourselves that we cannot really understand a generified problem until we've seen at least 3 occurrences of it, because before that it may be just a coincidence that 2 things are a little bit the same.
So what's the relation to dry? So dry would be don't repeat yourself, which basically says you shouldn't do the same thing twice. So is the rule of 3 that you recommend, is it a contradiction to the dry principle?
Yes, I would say so. And this is where you find an interesting, a friction appear, right? Because I'm basically saying that after 2 use cases, you don't know what the generic use case is yet, so that you can then just copy the code and have it in 2 places. But dry says you shouldn't repeat yourself, right? So you shouldn't copy code. So how does this balance? Well, I think it should be a deliberate choice. So if you're really, let's say, really into following dry to the letter, then yes, you should never copy code. But then the chances are that you're extracting generic solutions too early in your process and making the wrong abstractions. I think one of the things that my point of view about dry is that dry says that duplicated code hurts you, right? Because then you need to maintain code in 2 places. But this is not really a problem until you actually need to maintain this code. So a kind of controversial statement I like to make is that if you have duplicated code, this doesn't hurt you until you need to change this code. If it's just duplicated, it sits there, well, it doesn't hurt you, the code works. Not until you need to fix something and you fix it in one place and you need to copy the fix to the other place, or even worse, you forget to fix it in the second place, then it hurts you. But then we also shouldn't see that this hurting too heavy, because if it's a trivial fix in one place, well, we have regex search replace in our IDEs, right? So still being able to fix something in 2 places with an IDE shortcut, it still doesn't hurt you that much. Obviously, if you forget to fix stuff in place B, but you only fix it in place A, yes, then definitely it hurts. But I think we shouldn't be too dogmatic in applying dry everywhere. We should apply dry once we sufficiently understand the problem and the solution domain and can come up with reasonable abstractions that fit the at least 3 occurrences of the problem domain.
Mm-hmm. And because you just said that it's a controversial statement that duplicate code doesn't hurt you unless it is changed, I would actually argue that it's just a factual statement. You can't really disagree with it, and I think it's interesting because it basically gives the reason for the fact why we are afraid of duplicate code, which is that we need to change it in 2 places. So I think for that reason, I think it's a good point. So Dutro just said, for sure we tend already at the second occurrence to go with generic. So he has a thumbs up for the rule of 3. And Fabauti said on Twitch said, every time someone tries to prematurely dry up code, I like to talk about wet. Write everything twice. So WET. This gives me a nicer other cool acronym that allows for more thoughtful discussion.
Yeah, no, definitely. So I think you could see as too rigorous application of dry. You could see, I think, as premature optimization, because you have copied something and then you're not really sure whether you need to update this in the future or the code just sits there and it's fine. If you now already start extracting generic behavior and then later you find out that your third use case doesn't fit, then you've basically prematurely optimized your code. So from that aspect, I like wet as well as a statement. I still agree in general that we should try to avoid duplication when it hurts us, but it should be a considered decision and not something because you've read somebody write in a book that you shouldn't repeat yourself, right? There's still some thinking involved.
Yeah. one of the things that just came to my mind is when you're in a code retreat where you're doing this, where you're solving some problem and you're doing this loop where you're building stuff and then you're doing the testing and the refactoring and so on. To me, dry is a very important driver there to refactor the code. And it would be interesting to apply the rule of three there. I would just be very curious to see what happens. I'm not sure because on that level, it seems to me that dry is a very important driver to come up with better code structure. But I don't know.
I think it also depends on which scope you apply dry. So I'd say within one class, it doesn't really matter. You can be really rigorous in dry, all right? It feels fine to extract something to a method, etc. Because within the scope of one class, you don't really have much coupling, because coupling is something that happens at least between two classes, all right? So I guess if you're refactoring writing code with one class, fine. If it's two classes that definitely belong together because they are in the same, bounded context or in the same library or whatever, then maybe it doesn't also matter that much and feel free to extract and don't repeat yourself. But as long as you, at the moment when you think about genericizing something because it's duplicated and the coupling that this introduces may actually hurt you in the future because it's difficult to change, etc. Okay, this would be maybe the time that you start to be a bit more careful there. Because let's say that you have one team A has some logic in a service build, and then some other team wants this logic as well. Well, they can copy it, get it for free, use it in their service, and then they can move on independently from each other, which is fine. But if they extract it to some generic service or generic component, now they need to talk to each other and need to agree on how the shared code develops, right? So especially from the higher up you get in terms of layers from code, component, service, project, team, organization, I think the bigger the risks are of creating coupling by genericizing things.
Yeah, so that's, I think, a very good point. Astrid Zawadzki just said on Twitch, dry might also introduce unnecessary dependencies, which I think we just covered. Not sure whether you want to comment on it.
Yes, I guess if you see dry solving stuff with dry as genericizing stuff, introducing new components and having existing components depend on those, then definitely. And I guess that's exactly the same as what I said with generic solutions equal coupling. If you're talking about like external dependencies, that could also be the case, right? You don't want to solve something that's already solved somewhere in the industry, and then you're adding external dependencies. And adding external dependencies to your code also locks you in to some extent, because you may be dependent on updates from external dependencies, or you may need things from them that you cannot get. So there's nothing as flexible as simple code that you control. And I think this is something I read first in the Unicorn Project, the book about DevOps by Gene Kim. And he describes there the 5 ideals of DevOps. And one of them is locality and simplicity. So locality means that you have a solution in one place, that you can change it without needing to touch any other places around it. And locality typically implies simplicity. So if you have a local code, a class that you own, you can control, you can do everything you want to that class. But if you call an external library or a service by another team or a generic component that's used by multiple teams, you don't have locality anymore. And then you may exactly know what you need to change. You may exactly know which line of code in which class to change, but you cannot because it's a library maintained by an open source team, or it's a library maintained by another team, or it's code that other people also depend on. So from that point, keeping stuff local and simple typically allows you to speed up. And if you copy code, then it stays local, still duplicated, but copied. If you genericize something, it's not local anymore.
Mm-hmm. So just one thing. We did an episode about in German about choosing technologies for maintainable projects. And I think a lot of what you just said is stuff that we also covered in that episode where we were talking about dependencies to external libraries and how you should handle them and so on.
Is there anything in my career I found that slows you down? It's dependencies. And I'm not only talking about software dependencies, but dependencies between people, between teams, even worse, between organizations, etc. So one of the worst things for me is that when I know what needs to be done, but it cannot or won't be done because somebody else is responsible for this, right? So I think dependencies, whether it be between classes, on libraries, between projects, between teams, between organizations, they're typically the mother of all slowdowns, because then the problem may be clear, but the place where you need to solve it may be something outside of your control.
Mm-hmm. So Maarten van Stenbergen, which I assume is also a Dutch person.
I know Maarten, yes.
Yeah, so he has a comment or a question on our Slack. So he said, what do you think about the learning effect? Once you've seen some things, you have an instinct for generic versus specific by learning the hard way. But for people with less experience, it might be beneficial to create generic solutions, even if not needed yet, because you learn to implement a generic thing like creating, integrating a configuration business rule engine. Only by doing, you see the pros and cons to be used in future cases. If you apply specific, unless you gain less experience with generic solutions.
Yeah, it's actually a great point, right? If you don't have much experience in seeing pros and cons of both sides, how do you know that you're doing the right thing? And I guess we can zoom out a little bit and say that the same thing applies for if you're doing like software architecture work, right? If you're just getting started as a software architect, you cannot build on years of experience of what worked and what didn't work. How are you going to find out what works? So I think a couple of things can help there. Organize your train of thoughts and discussing with others to basically see what their ideas are. You can do like quick proof of concepts to get a bit more feeling about something. Typically, when I have an idea about solving a problem, I can think about it for as long as I want, but I'm pretty sure the first 5 minutes I start coding, I figure out some things I hadn't thought about, right? And the first 2 hours of coding, I can basically revisit my design because they're all things that surface there. So I guess the going into the wrong direction every now and then and learning the hard way is fine because there's a learning experience there. So I've also managed teams in the past where in the beginning, I wanted them to be perfect all the time. And whenever I saw someone was going in the wrong direction with a solution, I would stop them, tell them why I thought it was the wrong solution, and push them in the right direction. On the other hand, then you're basically depriving them of the learning effect, right? So sometimes I would also just see, okay, they're going in the wrong direction. How bad is this? How bad will they screw up if I let them continue? And if the answer is it will cost them a couple of hours, but they will learn something in return, or they will break something, but it won't break anything in production, fine, let them figure out. So I guess in the end, it's about any non-trivial problem you need to solve is look at the problem, think about the problem. What do I know about the problem domain? What can I come up with the solution domain? I see maybe these two solutions. One is this, pros and cons are that. One is this, pros and cons are that. Write this down, one A4 piece of paper, and discuss it with a couple of people who know the situation as well. I think that's, and then you can still get some of the learning effect. And you still get it wrong every now and then. So you get enough opportunities in your career to learn about this anyway.
Yeah, so I would like to add one thing because I think it's also about why this episode is important, and also the whole discussion that we're doing is important. So I think as an industry we have a bias, and you said that quite a few times. I think we have a bias for these generic solutions and for dry and these principles. So therefore, the discussion that we are having makes sense because it basically says, yeah, we have that bias and there are exceptions. And I think Maarten basically says it the opposite way around. He says, okay, he is afraid of people choosing this very specific solution in most of the cases, and therefore not seeing the problems with the generic solution. I think that's just not what we are doing in the industry. So I think it's important to see the bias that we have and take that into account. So I would assume that he gave the example of rule engines. I would argue that rule engines are probably overused to build generic solutions. So therefore, if we miss one opportunity to build one of those solutions and to avoid that common mistake, I think that's probably fine.
Yeah, so I think the idea with rule engines is that you make something really flexible, and that non-tech people should be able to change those rules and have a really flexible system, right? So I have a little story about flexible systems. Are you okay with me telling this?
Yeah,
this
sure,
story?
absolutely.
So I joined a new company, I don't know, years ago, and I was assigned to a project because this project was in trouble. And the project was in trouble because, they were all over time already. So it was a tender, so a government project that multiple companies could bid on, and the company where I worked had won this project. And this was a fairly simple registrational system. So it should aggregate data from all kinds of sources in one system. And then when I first joined this project, I set up my local environment and I loaded the initial start screen. And it took a couple of seconds. And I was like, that's interesting. Why does a simple start screen with 8 pieces of data cost me a couple of seconds to load? So I asked it to my colleague who was on the project for longer, and he said, yeah, there's a query going. So I said, I know a couple of things about query optimization. So can you show me the query? Because I don't know how to get it from the logs. And he said, yeah, I can show you the query. Are you sure? I said, yeah, I'm sure. Just show me the query. So I'll print it for you, he said. So he walks away. 5 minutes go by, 10 minutes go by. I was thinking he's forgotten me. He's drinking coffee. But then he comes back with a stack of paper about this big. I said, what did you bring there? Yeah, this is the query. It's only like, 5,000 pages of queries that I have here for you. Because in the end, it turned out that the data model was so complex, where you saw kind of an impedance mismatch between objects on the one hand, it was a Java application, and relations on the other hand, all kinds of things that were, what thing was loaded the list, every item in the list triggered loading this one. Yet we fetched the entire database in memory like a Christmas tree. So then my question was, why is this data model so complex? And he said, yeah, it was designed by the information architects. So what did they design? Yeah, their experience was that software was difficult to change. So they had been in a couple of previous projects, and once the software was delivered, it was hard to change the software. So to counter this problem, they designed a really flexible system. So what they did is basically every screen was configurable. There was like some stuff that was mapped to database columns, but every screen you could add extra fields, extra labels, extra items to a list. It was super flexible. And this kind of became a self-fulfilling prophecy. But because they designed the system to be so flexible, it became so complex that it became almost impossible to build and to maintain. We were still able to make it work a little, but then a small change request came in. And a small change request was that we should make it possible to also run reports over the data. Well, if you have a data model that is complex and this flexible, reports are going to be extremely difficult. So we said, oh, wow, that's going to cost us a lot of work. And then, the architects became a bit angry because how can this be so much work? It's simple reports. And then finally, we got to talk to the actual customer, but that was basically shielded by the architects. And we said to the customer, like, well, we get this change request now, making these reports, but that's really complex. Is this something new? How come we heard this now? No, this is the main requirement of the project, that these reports are in there. And they were like, so why, if this is the main requirement, we only hear this now, and then the data model is so complex, why we could just have it like a simple reporting scheme there? And then the customer said, I have no idea. And then we figured out that the people who had designed the flexible system were the culprits here, because they basically designed stuff that made the application more complex than necessary. The customer didn't need this complexity, and because of the design, we couldn't actually fulfill the actual complexity that the customer needed. So we were in quite heavy weather there at that point.
And I think that's also one of the examples that you gave in your talk. And I think the interesting part here is that you were actually able to convince the customer to change their ways. And also, I think it's an interesting lesson about how a generic solution seemingly makes changes easier, but really doesn't, because that's basically what
so
you're
on
saying.
paper it was really flexible, but because this flexibility was hard to build, in the end the system became hard to change. So indeed, but once we figured out that this wasn't going to work, well, we had two choices. Either try to make it work, but that didn't really work too well, or convince the customer that we needed to do something completely different. We we basically worked hard for a weekend, made a small demo of a really small system that did support this reporting by using open source reporting tools. And then the customer became enthusiastic. And in the end, we managed to basically rebuild a system with 2 people in 3 months, sitting desk to desk with the customer, continuously getting their input. And in the end, really simple software that did exactly what they needed. And we got to save the project. So I'm not really a fan of these heroic, let's convince the customer to throw everything away situation stories. But in the end, that was for us the only way to cut out the basically accidental complexity that was in there, because it was designed as a super generic solution, but it wasn't necessary. A simple solution was fine with simple reporting capabilities. That was what the customer needed.
And it's also a very good example of how you need to talk to like the real customer, not some man in the middle.
Yeah.
So we need to sort of go back to a subject that we covered a few minutes back. So basically what you said there is that depending on whether you're in the same class or in the same bounded context, the decision for a generic solution or a specific solution might be different. And Gertrude said, well, a DDD approach limit you to a given context and protect you from not creating a generic solution over the boundaries of a team context. So I think that goes back to that point where you said it's different. There is a difference between sharing a generic solution between bounded context or teams versus sharing or having that in the same class.
Yeah, absolutely. I think it's a good point. So if we look at domain-driven design, one of the things that DDD says indeed is the concept of a bounded context. So a bounded context is some piece of your business domain that coherently belongs together. And within this piece of business domain, you use the same language for the stuff that's in there. And then you should be really clear in what the boundaries of your piece of context are, and the interfaces of different contexts with each other. Because in one context, a user may mean something different than in another context. If we talk about finance or marketing or support, the fields you need to store a user are completely different. Indeed, once you go across different boundaries and you create coupling there, then you're mixing and matching different parts of your domains. And that may get you indeed in trouble. There's a comparison with a mantra that's used in the microservices world for a long time already, is that every microservice should have its own database, because otherwise you're basically creating coupling on a database level. Recently, I think last year at DevOps, I watched a talk from somebody who said, well, we should step away from this. 2 microservices can perfectly fine access the same database as long as they're within the same bounded context, because then they're still operating on the same piece of data. You shouldn't have the finance service and the customer support service go to the same database to fetch user details. But if it's 2 services within the finance domain, that may be fine. And this allows you to loosen this mantra a bit about integrating on database level, because otherwise, if there's 2 services that both need user data in the same piece of your domain, and you're artificially splitting those databases, then you need to move your integration to a different level. You may make it even more complex there. So I think definitely domain-driven design practices can help you on catching those things where it may not make sense to put generic relations and therefore generic coupling between those.
Mm-hmm. Yeah. So thanks a lot for that. There is this. So we had this rule of 3, And you gave that example of that system with the generic forms. Concerning the rule of three, there is also that example of that e-learning system, because when I talk about when I heard you talk about the rule of three, to me one of the questions is, on which level would you apply it? And in your talk you basically said there are different levels. So there's the code level, the team level that we already discussed. So and I think that e-learning system is a good example of how the rule of three is applied on not on the code level, but on a more coarse-grained level. Do you want to talk about that example?
That was interesting. So I was working for an educational publisher. An educational publisher make books for learning for schools, but this was about e-learning systems. So this was a company that had three business units. Let's say they were for primary education, so until 8 years old, secondary, which is 12 to 18, and then professional education, which is from ages 16 and up. And they were three different business units in the same company, with each with their own director, their own publishers, their own budget. And they wanted to move on in e-learning systems. And in essence, they all three ask the IT department, can you build us an e-learning system? And obviously, if you zoom out enough, it's three times the same system, right? You have students, teachers, lessons, assessments, and educational content, basically. So what we found there is that we quite quickly found out that organizationally, this was going to be a challenge. There was one IT department, but basically three customers that sort of wanted the same, but they didn't talk much to each other because, well, what does primary education have to do with secondary education? You know, one is below 12 years old and the other is above 12 years old. There's completely different in terms of learning material, but in terms of the actual functionality by the system, they can be fairly comparable. So they're basically like, there's a whole degree of how you can solve this from a tech perspective. So we could say, okay, those three business units, they all three want the same system. So we build just one system and then we give it to them and then they're good to go. But then when one of them may want to change something and the others don't want it, you have one code base, well, now you're in trouble, right? They've all ordered their own system and now they find out they're coupled to each other. You're going to have a fight. The other extreme would be to build three systems completely separate from each other. Then they would definitely not have any fights about functionality because they would all be the boss of their own system. But they are basically building the same system three times. So in the end, we kind of figured out a way in between, where as an IT department, we would try to see which of the technical components that are necessary for an e-learning system can we genericize. For example, something like managing user sessions, the fact that somebody is logged in. Well, the fact that somebody is logged in is not different for when you in primary or secondary education, for example. Or the way where we would get a data model for the educational content, or how we would get the educational content from the database. And in the end, we even brought up a team that would build and work on those generic components because we saw enough work on this area. But there basically, we kind of organized this from the IT department. So as an IT department, we mediated with the business unit and found out, okay, these are the things that we can probably do generic. And then still we can give them the feeling that they all have their own team building their own system, and they can also make project specific changes there. And I think there's what arises there is there's a big difference whether you're genericizing something from a technical perspective or genericizing something from a business or functionality perspective. From a technical perspective, you're typically at the back end of the building process. So you've had requirements, you have functional designs, UX designs, then you start building, and then you're thinking, I may be able to reuse this code. On the other hand, if you start all the way at the front and the requirements engineer figures out the stuff we're going to build here, I don't know, assigning students to groups, hey, this is actually the same in those three types of education. So if you start with thinking about generic solutions all the way in the beginning of your design process, you're probably going to be a bit more successful because then you can already think about, okay, so we can encapsulate this in this way, we can make it reusable by those three, and then we can pay for development with our three together, and then we only pay 1/3 instead of when somebody would build it themselves. So I think this is also a difference on whether you're already at the beginning of your process in the requirements phase thinking about generic functional solutions, as compared to when you're building, you think about generic technical solutions.
And I think if I remember correctly from what we discussed before, at the end, the product owners even came up with common features and common functionalities, and that made life much easier for you.
Yeah, definitely. But still, that was still fairly difficult, because it's not only about finding alignment on those features and functionalities, how it should work, but also having alignment in time. So one project may be a month ahead of the others, and they may have different needs than other projects. So in the end, I think to be really successful with designing generic solutions for multiple teams or business units or whatever, their priorities and planning also needs to be aligned. Otherwise, it's still going to be difficult.
Which basically means that at one point there is some impact on the planning and these kinds of things. And the thing that I like about that story is that it like literally talks about that rule of three, right? Where there are three cases, and then you would build the generic stuff, and you can even do that behind the scenes to some extent without the customer noticing. So I thought that.
Yeah, and the nice thing is that eventually the organization scaled to about 10 teams, and then we were really happy that we had those generic components that were already ready to use, because like the 5th project that started, they only needed like 1/3 of the time as the first project, because the rest was already there, ready to use.
So in that case, the sort of, let's say, modified dry principle, which is the rule of three, makes a lot of sense, and you shouldn't build those. You should probably stick to using those generic things. Talking about examples, the other example that I found is interesting is the CATS website. So do you want to talk about that?
Yeah. So we at Open Value, we've registered loads of domains around the world because we don't want anyone else to steal our name. So one of the domains we registered was openvalue.cat. So .cat is for the Catalan community around Barcelona. So when one of my colleagues found out that we had openvalue.cat, he said, well, we should have cats on openvalue.cat. So he created a site that listed all the cats owned by developers at OpenValue. And initially, this was a manually coded site with, I don't know, an Angular app, pictures and text of all those cats. If you go to openvalue.cat, you can see them live now. But then once change requests for this site were coming in, well, he was getting a bit annoyed because he needed to change the manual HTML, etc., etc. So after like the 3rd or 4th change request, let's say it was the 3rd because it matches to our previous story, it was the 3rd, then he figured out, okay, I may refactor this now because I'm getting more and more change requests in the future. So I'm going to go from a manually coded site to something that basically has a JSON file with the names of the cats and pictures, and then basically dynamically generate at least this cat website. And then we've had this live for a while, and then somebody started complaining. I said, what's wrong? Well, we have this website for cats, but I have a dog. And then I found out there's also a .dog TLD. So then I registered openvalue.dog, and now we need to make a dog website, right? So we only had one animal website yet. So applying the rule of three, we copied the cat website to the dog website, because we had already optimized the way of rendering a little bit. Now it's only a matter of adding dog pictures, dogs' names, etc. But still, we copied it. So now we have 2 code bases. So not until somebody starts complaining that we need, I don't know, a chicken website or an alligator website, this is probably when we're going to make a generic animal website component. But for now, it's just still 2 copies with the same code. And it doesn't hurt us at all. If we need to change something there, well, we need to do maybe regex search replace. But still, I think it's somewhat lighthearted, but still good example of the rule of three.
And I have to admit, I like this story because I'm not sure whether I would have had the courage to copy over the whole website to make it a dog website. And, you know, to me, it sort of, I might have made the decision to, you know, come up with that pet website that is a generic website, and then cats and dogs are the special ones.
Yeah, in this case, my point is that specific solutions are often a lot faster. Copying it and changing it was 10 minutes of work. Extracting a generic animals website would have made it be hours or days of work. Well, we don't know yet that we need it. If we get to build the 3rd website, okay, that may be the trigger that we can now genericize it. But we've saved until that third website is there, we've saved hours of work by copying it.
Yeah, maybe that's the other point. You shouldn't feel guilty about doing that, even though it seems it seems like a big no to do it, because at the end of the day, as you said, you're saving effort, you're saving time, and there's no real issue. So I think that's why it's a good story.
Yeah, and I guess the point is also that it's not a choice of no return, right? If you copy something and you feel really bad about it later, or you have reasons why this was a bad idea, it is not more work to first copy and then genericize it compared to making a generic from the start. That's maybe a difference of an hour or something. So this is not an irreversible decision. And if you decide to make a generic right away, then you do have the risk that you choose the wrong abstraction and build something that will actually cost you more time to make a generic at a later stage. So this is also a bit with postponing those decisions. As long as it's a reversible decision, do whatever the simplest and fastest thing is for now. If you feel bad about it for reasons or later, you can always make a generic afterwards. But if you made the wrong generic choice, it may be harder to go back to the correct generic choice.
Yeah, so that's about the last responsible moment, and the question becomes when the last responsible moment is to generalize anything. Yeah. So Fabauti said 17 seasoned full snack experts. Love it. And maybe I guess that's some kind of quote from either the dog or the cat website.
So we have full stack experts at Open Value, and then the cat's websites are full snack experts.
Yes. Oh, I see. Okay. Yeah, and they are quite picky about their snacks, probably. Coming back to the point that we made about that e-learning system and the 3 departments. So Deirdre said, IT is a good mediator. In my humble opinion, the better one as than a product owner, because of the technical knowledge. You can better mediate offer solution than POs, which is mostly not so affine in its solutions. So I guess the point that he's trying to make is that as IT experts, we are the better mediators because of our technical knowledge and not POs. Yeah. And he continues, of course, the POs are needed because at the end we hope that they are mastering the domain knowledge.
Yeah, so I think I agree. Because, and I've often seen this in projects, and somebody comes up with an idea. Let's build this and this new feature, and then you're looking at this with the team and thinking, wow, that's fairly complex. But if we change this small thing, then it becomes a lot easier to build and to maintain. So I guess this feedback loop is something that's difficult for less technical people to make, right? And as a developer or an architect, you can also reason about dependencies and coupling and different ways to genericize things. Whereas from a product perspective is basically, you could think about how a system works and features and look and feel. And that's basically it. But there's no such abstract concept of reusability when you're talking about functional design of software. Sure, you can maybe talk to different people from different areas in a company and talk about, if we design it in this way, would it be usable for you? But then still the concept of reuse is quite intangible for someone in the functional domain, right? And what we also see is that one thing that people who need to describe what they want in an IT system are not good at is describing what they want in an IT system. Because often you see that I used to work at a company where we would do like hugely detailed functional designs. We'd go to the customer, do design interviews, draw things out, write everything in a document, screenshots, everything was perfectly described there. So then we send this document of 80 pages to the customer, they read through it and say, okay, this is what I want. Check mark, stamp on it. Then we build exactly as described, we give it to the customer, they start testing, and they say, yeah, but this is not what I meant. What do you mean not what I meant? Well, I meant this and this and this. But we've talked to you, we've written down what we thought you meant, you've read this and agreed on this, and now you say you meant different. Yeah, you've built what you wrote down, but it's different from what I meant. So I guess the other problem is also that you don't really know how a system works and feels until you're actually using it. So I guess that's why it's also more difficult to reason about generic from a product perspective compared to a technical perspective.
Interesting, because I have to admit that I understood the story about that e-learning system somewhat differently. So because you gave that example about how you would come up with that one solution for user management, like whether users logged in, and that's clearly a technical thing, and obviously IT people can decide about that and should decide about whether this should be a generic component. And it seems, but I'm not sure, maybe that's the misunderstanding. It seems that at one point, product owners came up with common features, and that sort of took you to the next level, and is something that you couldn't do if you're just among the technical people. So that they at one point figured out, okay, this is something that we can have in all of the three, and then later on the other systems as well. And to me, it seemed like, if that's the case, then it seems like we are limited as purely technical people to those technical solutions. While if you want to have something that is reusable or generic on the business level, then you need to have the PO, which means that dude root is somewhat wrong, because the POs also need to think about generic solutions and the business solutions.
Yeah, now you're absolutely right. I think the point was that we started out with, from the IT side, figuring out which technical components we could make reusable, like user management, session management. And then, once we had done this, then we started telling to some of the business people, okay, we were able to get started and get you like a working application shell in 2 days, because we were using generic stuff that was built for the other teams, right? And then they kind of got interested in, so if we build stuff generic, we can actually save time and money. Why? Yes, it's maybe a bit more difficult and a bit more time to do it the first time, but we could probably agree that the first team to design and build this, they can build a specific. It's, 2 weeks. They can build generic. It's 2.5 or 3 weeks. But then once the other teams start using this, they may pay you back for part of the effort, right? And then some sort of economy arises. But still, we found that in order to have those discussions of how to make something generic, this is not you can do purely from the product side, because you need to think about technical implications and reuse as well. You can design a screen and cut out this screenshot and paste it in your documentation 3 times, but that doesn't mean that it's going to work as a generic solution. So there we kind of got them interested by showing it's possible to reuse those things, and by explaining the technical possibilities, while still keeping an eye on getting coupling as low as possible, we were able to start working together on designing actual functional, generic reusable things.
So it's still a collaboration. So between technical people and product people. So let me see. For sure, the PO, dude root said, for sure the PO could be the one which comes with solutions like what is coherent and belongs together. Yeah. So we are almost at the end. So what are some good or bad reasons for generalizing things?
Yeah, I think, let's start with the bad ones, because those are the most fun.
Right.
We've always done it like this. And if you keep saying that, then we'll always keep doing it like this, right? So don't think back about how you've done it, but think about how you want to do it in the future. We don't want to depend on libraries. Well, why not? Probably the library maintainers are better at it than you, and they've spent more time and more people use it. So, okay, not really good reason. We need to be future-proof. Sure, but we also know that we cannot predict the future, right? So you can be future-proof by writing really simple code. Because the product owner wants it, well, the product owner can design functional stuff, but once it's about technical generic solutions, it's a choice from the team. Or because the architect wants it. And this is one of my favorite examples. The architect, I think if the architect tells you to do something generic and then it's the team's problem, then the architect is manifesting itself as a seagull architect. So this is a pet peeve of mine. The seagull architect is an architect who flies over the team like a seagull. Every now and then flies down, shouts, "Wah!" and shits on the developers, steals their French fries, and flies back up again. And the problem there is that the shit is only going down. So there's no feedback loop. The shit should be going up as well. So if the architect tells you that it should be generic, well, they should be ready to defend whatever their statements are there. They should also feel the pain and get the feedback loop from the team building it. because and therefore I think the architect should also be part of the team and also be able to be convinced to move back to a specific solution if this wasn't the right idea. Turns out to not be the right idea. So if you then move to the valid reasons, the rule of three, if it checks out. Third case, you can go generic. If you're pretty sure you're going to need it almost everywhere, so let's say logging, metrics, tracing, any cross-cutting concerns, makes sense to go generic. If it's something that you're pretty sure that a lot of teams will use, you have, some kind of internal service, and you have built an API for this or an SDK that you can distribute to all those teams. If they're all going to use it, fine, you can put it in a library. And another one is also interesting that a colleague of mine came up with. If it's something that requires skills that only a couple of people have, or it's really complex logic, like, encryption or password handling or something like this, you only have a few people who are ready to work with this. Then if you genericize it, genericizing something is also forms encapsulation, because if you make it generic and you have a well-defined API, nobody else can change it, then only those people who are experienced with it can work with it. And I think finally, if it's pretty sure that the gains are bigger than the cost, if it's really easy to reuse and make it generic, by all means go ahead, because that's often a hard call to make, that the gains are bigger than the cost.
Right. Okay, so thanks a lot. Thanks a lot for being here. Any other things that you would like to add?
Yes, if there's one advice I may give on how to handle generic versus specific at any point in the future, it's really simple. It's to write simple code.
Yeah. Thanks a lot. And that actually applies not just to generic versus specific, but also to a lot of other things. So thanks a lot. Just a reminder, so Bert Jan will also talk about a talk at the Software Architecture Gathering, and there is a rebate code for 15% off. And have a great weekend, and enjoy the weekend. And as I said, next week we will have one episode with Kevin Goldsmith about organization and architecture, also a Software Architecture Gathering special. And on Friday, we will have an episode that talks about functional architecture. So we will actually go through an example of functional architecture with Mike Schrijver. Okay, thanks a lot and have a great weekend.
Thank you.